Ever wondered why things always fall down and not up? This is a question that might seem obvious, but it's actually rooted in a daily mystery that often goes overlooked. Gravity. Gravity is like that friend who's always there, no matter what. It's there when you're walking your dog, keeping you and your furry friend firmly on the ground. It's there when you're sleeping, making sure you don't float off into your dreams. And it's there when you're just sitting, keeping your chair right where it should be. Yet despite its constant presence, gravity remains a puzzle. It's an unseen force that influences everything we do, from the mundane to the extraordinary. It shapes our lives in ways we seldom stop to think about. Imagine a world without gravity. Things would be floating around, and life as we know it would be completely different. So gravity seems to be an invisible force pulling us down. But how does it really work? To understand gravity, we travel back in time to the 17th century, with a man named Isaac Newton. Imagine a young Isaac Newton seated under the shade of an apple tree on a sunny afternoon. As he was engrossed in his thoughts, an apple fell from the tree, landing with a soft thud on the ground. This seemingly ordinary event, however, sparked a question in his mind. Why did the apple fall straight down instead of going sideways or upwards? This simple question led Newton to his groundbreaking theory of gravity. Newton began to ponder and probe. He observed that not only apples but everything that is dropped falls towards the ground. He noted that the moon, although much further away, also seemed to be falling towards the earth, but in a perpetual curve due to its forward motion. This led him to a revolutionary idea. What if the force that pulls the apple to the ground is the same force that keeps the moon in orbit around the earth? He proposed that every object in the universe, no matter how large or small, attracts every other object with a force that is directly proportional to the product of their masses, and inversely proportional to the square of the distance between their centers. This became known as Newton's law of universal gravitation. But what does this mean in simpler terms? Imagine you're holding two magnets. The closer they are, the stronger the pull between them. Now, if one magnet were much bigger than the other, the pull would be even stronger. That's essentially how gravity works. Newton's law of gravity was a game changer. It not only explained why apples fall from trees, but it also shed light on the motions of planets, moons, and stars. It allowed us to predict the movement of celestial bodies with great accuracy, paving the way for space exploration and our modern understanding of the universe. And that's how an apple led to a groundbreaking discovery. So, what exactly did Newton discover about gravity? Well, let's dive right in. Imagine you're Sir Isaac Newton sitting under an apple tree. An apple falls and you wonder, why does it fall straight down and not sideways or upwards? This question led Newton to his groundbreaking discovery, the law of universal gravitation. Now, what's this law all about? In the simplest terms, Newton's law of universal gravitation states that every single object in the universe attracts every other object. Yes, you heard it right. Every object, from the tiniest speck of dust to the largest star, pulls on every other object. But how strong is this pull or this force of attraction? That's where the law gets a bit more detailed. It tells us that the force is directly proportional to the product of the masses of the two objects. This means if you double the mass of one object, the force doubles. If you triple the mass, the force triples, and so on. But there's another factor at play here: the distance between the two objects. The law states that this force of attraction is inversely proportional to the square of the distance between the object's centers. So if you double the distance between two objects, the force of attraction becomes 1/4. If you triple the distance, it becomes 1/9, and so forth. This might sound complicated, but it's pretty straightforward when you break it down. What it essentially means is that the closer objects are to each other, the stronger the force of attraction, and the heavier the objects, the stronger the force as well. So next time you see an apple fall from a tree, remember that it's not just falling towards the earth, it's also pulling the earth towards it, even if by an incredibly small amount. And it's not just the apple and the earth. You, me, the stars in the sky, the farthest galaxies. We're all pulling on each other all the time. In other words, everything pulls on everything else in the universe. If gravity is pulling everything together, why don't we see things crashing into each other? Now that's a question that has surely crossed our minds at one point or another. And the answer lies in the concept of gravitational balance. Gravitational balance, in its simplest form, is the perfect balancing act between gravitational force and other forces at play. It's like a dance, where all the dancers know their steps and keep in rhythm, creating a beautiful performance. In the same way, gravity works in harmony with other forces to maintain balance in the universe. Let's take our Earth for instance. It's constantly being pulled towards the sun due to gravity. But if that was the only force at play, we would have crashed into the sun a long time ago. So why hasn't that happened? It's because there is another force at play here. The Earth's momentum. This is the force that keeps the Earth moving in a straight line. The gravitational pull of the sun and the Earth's momentum work together in a delicate balance. The sun's gravity pulls the Earth towards it, while the Earth's momentum tries to keep it moving in a straight line. This tug of war results in the Earth moving in an elliptical orbit around the sun. So, in essence, gravity is not a destructive force that causes chaos by pulling everything together. Instead, it's a force that works in harmony with other forces to maintain balance and order in the universe. It's like a master conductor, guiding all the elements in the symphony of the cosmos. And it's not just about the Earth and the Sun. This principle of gravitational balance extends to all celestial bodies in the universe. Each star, planet, and galaxy is held in place by the delicate balance between gravity and other forces. This invisible force, this gravitational pull, is responsible for the structure and order we see in the universe. It's an unseen guiding hand, ensuring that everything stays in its place and moves in harmony with everything else. So gravity is like an invisible glue, holding the universe together. We've talked about gravity on a universal scale, but what about its effects on our daily lives? Gravity, my friends, is the unseen puppeteer, the silent conductor, orchestrating the rhythm of our everyday lives. It shapes our world, our actions, and even our very bodies in ways we often overlook. Take a moment to consider your walk. Each step is a negotiation with gravity. We lean forward, letting gravity pull us ahead, then we catch ourselves with our foot. It's a dance we've all mastered, so much so that we rarely give it a second thought. Now, let's think about something as simple as a dropped object. Whether it's a feather or a hammer, gravity pulls it towards the Earth, creating that familiar scene of things falling down, not up or sideways. This predictable behavior is all thanks to gravity, a constant in an ever-changing world. But gravity isn't just about falling objects or our unique gait. It's the force that holds our atmosphere in place, allowing us to breathe. It guides the flow of rivers from mountains to the sea, carving landscapes along the way. It even influences the way plants grow, reaching for the sun while staying firmly rooted in the ground. Understanding gravity has also been the key to some of humanity's greatest achievements. It has helped us fly, defying the pull of the Earth to soar in the sky. It has allowed us to sling spacecraft across the solar system, using the gravitational pull of planets as a cosmic slingshot. And it has given us the ability to predict the motion of celestial bodies, unlocking the secrets of the universe. And yet, despite its omnipresence, gravity remains a humble force. It doesn't shout about its importance, it simply is, asking for no recognition, yet influencing everything. So, you see, gravity is more than just a force that keeps us grounded. It's an integral part of our existence, a constant companion in our daily lives, and a cornerstone of our understanding of the universe. A silent conductor indeed. So we've traveled from a falling apple to the edges of the universe, all to understand gravity. It's been quite a journey, hasn't it? We've seen how our daily lives are shaped by this invisible force. From the moment we get out of bed to the time we spend playing our favorite sports, gravity is there, constantly pulling us towards the Earth. But it's not just about us. It's about the universe too. Gravity is the force that holds the moon in orbit around the Earth, that keeps the planets in their paths around the sun. It's the force that shapes galaxies, that pulls light around black holes, that has been at work since the beginning of time itself. It's simple and complex, everywhere and invisible, shaping everything from the smallest dust mote to the largest galaxy. It's the constant in our ever-changing universe. And that's the magic of gravity, the invisible force that shapes our lives and our universe.